This is FreeCAD. It's open source. It does full 3D CAD and full CNC toolpath generation in one application, and it's been doing it since before most of the paid alternatives decided subscriptions were a good idea. If you've been using SketchUp to design your projects, or VCarve to run your toolpaths, or any of these other programs, this series is going to change how you work. Not because those tools are bad, they most definitely are not, but because you've been using two separate tools to do a job that one can handle, and that one costs nothing. In this first video, we're going to download FreeCAD 1.1, take a quick look at the interface, build a simple part, and use something called a VarSet to make that part parametric, which means it can change dimensions without you rebuilding it from scratch. That last part is something most of the alternatives simply cannot do. Before we download anything, it's worth 30 seconds on why FreeCAD specifically. There's a handful of tools that woodworkers and CNC makers tend to reach for. SketchUp is popular, and it's excellent for visualizing joinery, but it doesn't generate toolpaths. You need a separate CAM application. It's also not truly parametric. Change a dimension in SketchUp, and you're often rebuilding, not adjusting. VCarve Pro and Aspire from Vectric are serious CAM tools. They run machines well, and I own and use VCarve Pro for certain things. Unfortunately, you need the more expensive versions of the software, such as Pro or Aspire, to create anything beyond flat 2D. And these carry a price tag that's meaningful for a hobbyist shop. Fusion 360 does both CAD and CAM, and it does them well, but the free version has limitations. You can only edit 10 projects at a time, not a huge issue, but using what you create commercially is an issue, and its free tier has been getting smaller every time Autodesk reconsiders its generosity. The paid form is a subscription and not a cheap one. It also is cloud dependent, which can be a limitation for some. FreeCAD is a powerful alternative. It does CAD, it does CAM as well through a separate workbench called, shockingly enough, CAM, which we'll cover later in the series. It allows output to PDF format for free. It has unrestricted commercial usage for anyone who uses it, such as small shop owners. Importantly, as we'll see, its user base is active and the program is getting better all the time. It's an open source program with all the advantages that entails. It runs entirely offline and locally instead of in the cloud, and it costs nothing. Finally, FreeCAD is fully parametric from the ground up, which means it was designed around the idea that dimensions are variables, not fixed values. The main downside is that there's a fairly big learning curve, but that's what this video and others like it are all about. Let's start working in FreeCAD. Go to freecad.org, click Download. You're looking for version 1.1.1. That's the current stable release. Choose your platform, Windows, Mac, or Linux. On Windows, grab the installer and run it, accept the defaults. On Mac, it's a standard DMG drag to applications. For Linux, I don't know much about Linux, but it is supposed to be pretty straightforward. Let's get into FreeCAD now. When you first start FreeCAD, this is the screen you'll see. We're going to start with an empty file. This is the way that mine appears. It's a little bit modified from what will happen when you open it up, but in general, you're going to have workbenches across the top. You're going to have tools below it. The workbenches will show up in a drop list on the standard appearance. On the left is the tree view, and that's everything you do in order, so that you can go back and modify things earlier on in your process. On the right is the task panel, and this is focused based on what you do for a specific activity you're in the process of working on. In the middle is where all your work happens. Up on the top, you're going to notice what are called workbenches, and we use different workbenches for different things. As we click on a workbench, you'll see that the tools below it also change. Mine are set up as tabs. Yours will initially be a drop-down box, but there's a way to change that if you'd like. We primarily use things like CAM for making toolpaths, TechDraw for making technical drawings, but we really work mostly in part design and Sketcher. You make a 2D sketch in the part design, then you expand or pad it to create a 3D object. The first thing we want to do is create the variables we're going to use for our box. So you click on the VarSet icon and you get a VarSet as the first object in your tree. It will also pop up with an Add Property box that you see in the middle of the screen. When we put a name in, we can put the name as anything we desire that we'll remember, But if you're going to use more than one word, there can be no spaces. So you can use underscores or hyphens. I tend to use underscores if there's multiple words, but you'll get an error message if you try to add a space anywhere in the name. So we're going to add length. The group can be just the base group. If you have a bunch of variables, you might add different groups, and then you add the type of variable it is, length, integer, angle, and then you put in the value. We'll put in a value of 10 inches for the length of our box, and click add. You're automatically taken to another add property, so we're going to add a width, and that width is going to be 6 inches, and we're also going to add a height, and that height will be 2 inches, then we can close it. So when you click on the VarSet, we could rename it by right-clicking. We'll just leave it as VarSet. But when you click on it and look in the property value area to the bottom, you're going to see the values that you've put in. And you can change those directly later on if you want to. What we're going to do now is add a body to our file. Click on the new body icon. The body is kind of a container where everything happens. And so this is where we're going to start with our sketch, and we're going to end up extruding or padding that into a 3D object. So when the body is highlighted, we can go ahead and click on the new sketch icon, and then we click the plane we want. So we'll take the XY plane, and now we've got our X axis, our Y axis, and the origin, and you'll see we're automatically switched to the Sketcher workbench. And there are a bunch of different tools to work in a Sketcher workbench. We're going to start with a rectangle. There's a few different rectangles we can create, but we're going to do the corner-to-corner rectangle. You click once, move your mouse in another direction, click again, and you've created the rectangle. We're not going to use this one because we need to constrain our rectangle. Constraining is allowing the software to know exactly where you're starting from in relation to something the software appreciates. Here, it's the X and Y axis and the origin. So we'll click once at the origin, move the mouse, click a second time, and we've created our rectangle. Now we have a rectangle in gray or black lines, which means it is not constrained. And you can see that on the task panel to the right. Now we select the horizontal top, the dimension tool, and then you're going to see a length. But instead of doing that, we're going to hit the function key, and we start typing VarSet. When you hit the V, you're going to see VarSet pop up below, and you can either click on it with the mouse or use your down arrows on the keyboard to highlight it, and then hit enter. And then your different variables are going to pop up. We want length, so you can either click on it directly or begin typing length, use the down arrows, and hit enter, and then hit OK or enter again, and hit enter again, and you've got 10 inches. Now we can do the same thing for the vertical. Get to our VarSet and find our width and click enter. Now you can see that the sketch has turned completely green, and the taskbar says it is fully constrained, which is what we want with every sketch. The software knows exactly where all the lines are compared to the origin. So we're done with the sketch, and what we can do is close it, and now we can pad it or extrude it to make it into a 3D object. So we click the pad button, and in the task panel you're going to see length. Well, we have a height, so let's click the function VarSet height, hit OK, and OK, and now we have actually a cube rather than a box, but with dimensions that we specified before we began even making it. So if you look in our VarSet and we decide maybe we should change one of the variables, let's click on the 10 for length and make it 20 instead, and hit enter or click outside the box, and now everything stayed the same except the length. And you can do this for any of the variables. So we can get it back to 10, we can change the height, we can change the width, but by setting the variables ahead of time, you have a lot more flexibility down the road. For a simple project, VarSets are a mild convenience. But if you have something very complicated that reference all kinds of different things, it's a difference between a 10-minute adjustment and an afternoon of redrawing in tears. So that's the foundation. FreeCAD installed, interface oriented, VarSet wired into a live model. In the next video in the series, we're going to take it a little further, create an actual functional L-clamp for your CNC wasteboard, use parameters to make several sizes of that clamp, and starting to think about how that part becomes a tool path, which we can turn into a part in real life on the CNC. If this is your first time here, the channel is the Articulated Workshop. Everything we build is designed to run on real machines, cut real wood, solve small business problems, and generally make the digital side of your shop less of an obstacle than it usually is. We also love 3D printing because 3D printing and CNC work just do the same thing and use the same software, just in opposite directions. One takes stuff away and one builds it up. Subscribe if you want to follow the series. There's a link below to download FreeCAD 1.1 if you want to work along. See you in the next one.